Okay, this is multi-dimensional arrays. Um, where before we just had a single set of brackets, here we have two sets. This is a two-dimensional array. So if you've had college algebra, your matrix has rows and columns. You can think of it that way. It's not quite the same principle. Um, so another two-dimensional array here. You see, you can put the brackets here, or you can put them after the name, or you can split it up, which is kind of weird. And this is a three-dimensional array because you got the two brackets after this one called space, and then you got a one after the int. So that'd be a three-dimensional. Here's how you define it. Um, so you got your string, and then your brackets, and then rectangle equals new string, then three, and then two. So this is an array rectangle with three elements. Each refers to an array of two elements. You can think of the addressable range as 0, 0 through 2, 1. But again, they say don't put commas between it. You have to do brackets like that. So this is how you set it equal to a value. Um, multi-dimensional array is nice if you're doing mathematical programming. If you've worked with matrices before, then you can program it in terms of matrices. Sometimes it's a challenge to figure out how to. I didn't cover this already, did I? That's weird. 1126. Oh, okay. I was just saying, I was pretty sure we left off right here. Okay. But I remember, like you said, I remembered the adding and subtracting, and I failed miserably, I think, on multiplication, didn't I? Yeah. Um, it might be kind of, or if I could figure out how to do it, might be kind of fun to play with matrices again, like Gaussian elimination from college algebra. Okay, so let me project. And we'll see how this goes. Okay, right click on that, choose Java class. I don't think I programmed this for 20 years. That's been longer than that. It's been 30 years. Let's see, int matrix A is equal new int rows by columns. Um, by three. Yeah, obviously not using new because it's not an instance. Yeah, no, it is. Yeah. Yeah, I do. Okay, so A. Let's see. X plus 3x plus 2y equals 5. 7x minus 4y is equal to 3. And let's see if I can get the syntax right here. Okay, quotes around it. This would be probably easier. 3, 2, 5, comma, 7, negative 4, 3. I don't think I want that anymore. So for int rows equals 0, continue while rows is less than or equal to 1. Rows plus plus. For int columns equals 0, columns is less than or equal to 2, columns plus plus. System.out.printf percent %d percent %f %.2f space comma a rows columns. Change that to a double. And outside of that, I want a print line, system.out.println. Then run that. That looks right. Now with Gaussian elimination, you want to take your matrix and you want to get a 1 here. Remember Gaussian elimination? Yeah. So you want to get a 1 here, and then you go down to diagonal and you want to get a 1 here. So we want to loop through our rows. So for int rows equals 0, continue while rows is less than or equal to 1. Rows plus plus. So for each row, which row corresponds with column, I'd want to first divide everything by the number right here. So I'm going to say, I need my columns to change too. So for int columns equals 0, columns is less than or equal to 2, columns plus plus. And I need to record off the number. And down here, I'm going to say temp is equal to A rows. Okay. And then I want to divide everything by it. So A rows columns is equal to A rows columns divided by 10. Now I'm gonna have a method here. Void print matrix. So I can call this over and over to print a matrix. So after I do this, I want to call that. So print matrix A. Double. Okay. So let me up here print my matrix A. Now here we got 3. So the first pass through should divide everything by 3. 3 divided by 3 is 1. 2 divided by 3 is 0.67. 5 divided by 3 is 1.67. And then in my second row, it goes to my next number here, which is -4. And it'll take 7 divided by -4, which is, I guess that. -4 divided by -4, which is 1. And 3 divided by -4, which is -0.75. So that part's working. I was just working the diagonal down there, getting 1s there. That's not actually how you do it in algebra. You have to get a 1 here first, and then you have to get a 0 below it. So that's the next thing we'll tackle. Is now we got a 1 there. We work at getting 0s below it. That's the challenging part. So I'm still sitting on row 1. So under row 1 here, this gets 1 on the diagonal. This needs to get 0s below it. So I want to go for int rows 2. I want to start at the next row. So if I'm currently sitting on rows, my next row would be rows plus 1. And I want to do a rows 2 while it's less or equal to 2. You can't do the next one if there isn't a next one. Rows plus plus. That makes sense on that? And so then at that point, it's always the same. So like if I have a 1 here, I'm going to take -1 times this number and multiply it times this number. Okay, let me think this through. Let's see. If I have 3, 2, 5, 7, -4, 3, divide everything by 3, and we get 1, 2/3, 5/3, 7, -4, 3. So our step would be to take -1 times the 7 and add it to the 1. And this is our new row 2. So -1 times 7 is -7 plus multiply. There it goes. -1 times this 7 gives -7 times this. I'm trying to think of a program actually, just thinking from algebra. What we're going to do in algebra, that'll help me, I think, is we always take the opposite number of this, -7 times row 1, and we add that row 2. And that gives us our new row 2. So -7 times 1 is -7 plus 7, 0. -7 times 2/3 gives you whatever plus the -4. So this is what we want to accomplish. So we need to figure out what number to multiply everything by. So that factor right there. And it will always be -1 times whatever this is. Let's see. Temp is going to equal -1 times a rows 2 rows 2. I don't think that's right. So definitely be rows 2 should be in the same column as this, so shouldn't it? System.out.printf temp equals %d %f %.2f /n temp. It's like an infinite loop to me. Interesting. Oh, it helps if you increase the right variable. Rows 2. There we go. Index 2 out of bounds. Rows 2 equals rows plus 1. Which would be a problem if it was on the second row, which is actually 1, because it increase it, but then this should handle it. Oh, except for I don't have 2 rows, do I? I mean, I have 1. Because it goes 0, 1. That's why I blew up. Guessing. Okay, so temp is equal to 4. It shouldn't be 4, should it? It should be -7. So that means I got my code wrong there. So instead of rows 2, this should be back 1. Temp is equal to -7. Okay, so that's perfect. So, because when they're the same, it's a diagonal. So the column should be back 1. And a lot of times I have trouble visualizing that. I have to just try it and see, and then think about, oh yeah, it should be back 1. So then we want to take that number we just came up with, we'll multiply it times what's in row 1, and we'll add that to row 2. Okay, so here's a trickier part. That's correct, so I'll leave that alone. So A rows 2 except for now we need to look through all the columns. So for int columns equals 0, continue what columns less than or equal to 2, columns plus plus, then rows 2 columns is going to equal to rows 2 columns plus A rows 2 columns. Okay, so we're going to have our -7 in here. So we're going to have our temp times. Now row 1, that would be the previous row, which means this should, in theory, be a -1. So that's my previous row. And then this right here, row 2, should be the row I'm currently on, since I'm doing rows 2. Does that make sense? -0.00. Should be 0. I'll go with that. Okay. Yeah, that's probably right. I unfortunately made my answer so it's x equals 1 and y equals 1. So this would tell me that y is equal to 1. Let me go change that to something a little bit more challenging. Like, if I wanted x to be x equals 2, y is equal to 3. So that gives me 6 plus 6, 12. This one give me 14 minus 12, 2. And it should give us y is equal to 3 now. So let's see if that's a true statement. Yep, y is equal to 3. Now that's the Gaussian elimination, where you could go then do a backward substitution and so forth. The Gauss-Jordan elimination said you're going to go back up the diagonal, going back up this way, and get zeros above this one. So like this one here, I want to get zeros above it. Back up. Okay, get zeros below it. This is Gaussian elimination. Now go back up the diagonal and get zeros above it. And this is what's referred to as our Gauss-Jordan elimination. Start at the last row and go back. For INT, rows 2 equals to, how many rows are there? 1? Because remember, it starts at 0. Continue while rows 2 is greater than or equal to 0. And rows 2 minus minus. Okay, so I'm going back up the matrix, which in theory I should be right here, which is rows 2, rows 2. I need to get my temp number, which is -1 times this one. So temp would equal -1 times A rows 2 minus 1. One right above it. And columns, no, rows 2. Rows and columns. System.out.print f temp equals %f/n temp. And another infinite loop. Boy, I'm getting good at those. Helps if I decrease the right. Starting at rows 2. Continue while it's not equal to 0, but it's greater than 0. No. Okay, so our temp is negative points this. So that looks right, doesn't it? Okay, so now we're going to take that temp number. Let me think about this from a math standpoint. We got 0.674, 0, 1, 3. So I want to take that negative 0.67 times row 2 and add it to row 1 in my new row 1. So, through all the columns, so for int columns equals 0, columns is less than or equal to 2, columns plus plus, a rows 2 columns equals temp times a rows 2 columns plus a rows 2 columns. I think I got something messed up there. Brace. There we go. Okay, row 2 is the row I'm currently on. Row 1 would be the previous row. Which means this would be a minus 1. This is going to be my new row 1, which is my previous row. So I think it'll be that. See how if you write it out from an algebra standpoint, you can kind of think about which row am I dealing with. I would have just been guessing otherwise, trying to put minus 1s here. Still might not work, but at least it gives me a logical approach. And 2, 3. So our Gaussian-Jordan elimination is working for, this is RREF on the calculator. Remember RREF from college algebra? It's a method on the calculator. You can plug it in, it just gives you this. But that's RREF on the calculator. Question is if it works for a larger matrix. If it doesn't, I'm not going to try to fix it. 4x minus 5y plus 3z equals something. 5x plus 2y minus 7z equals something. 8x minus y minus 4z equals something. And I want x be 1, y is equal to 2, z is equal to 3. So that's 4 minus 10, negative 6, plus 9, 3. 5, 9, 9 minus 21, negative 12. 8 minus 2 is 6, minus 12 is negative 6. So in theory, if I did my adding and subtracting right there, 4, negative 5, 3, 3, 5 to negative 7, negative 12, 8, negative 1, negative 4, negative 6. The problem is that I've hard-coded some values here. I don't know if I can refer to the size of the array or not. Let's see. A dot length. Sometimes when you find yourself hard coding, then it's better to hard code it up above. Rows equals 2 int, columns equals 3. So initially, I had this going to 1, which is 1 less than row, isn't it? So rows minus 1. I had this one going to 2, which 2 is 1 less than columns, since I'm dealing with columns. Yeah, columns minus 1. Here I had less than or equal to 1, so that's going to be columns minus 1. Columns, where'd that come from? Rows. Columns minus 1. And down here, rows minus 1. Columns minus 2. Columns. Integers. So when I call print matrix, I want to pass in rows and columns. And rows and columns. Now, assuming I didn't miss any, now it's no longer hard-coded down there, it's hard-coded up here, which isn't a whole lot better, but I can change it in one place. Yeah, it's easy to change then. You don't do much thinking, you just go up there. See, my code's not working, is it? This is what I had originally. Where's my other column at? Columns minus 2. Where did that come from? 1. Almost looks like it didn't go all the way down. Like here when I'm getting zeros below it, see how it stopped 1 short? That might be something I can easily fix. Let me go back and see. So that's a problem with getting zeros below it. Almost implies I'm not going down enough rows. Let's see. I'll probably break it. Yep, that broke it. Row 2 equals row 1. 3 rows, 4 columns. Temp is equal to -5. Temp is equal to 1. Print matrix A rows columns. Let's see what it looks like. Let's try it again. Let's see. System out print line. Okay, so initially, so let me get down to the right program run. There's still got something wrong. That looks better. -5. I'm assuming this is still 1. And then -5, so that'd give me a 0 here. Except for it's not handling this, is it? Oh well. At least I got to working for 2 equations, 2 variables. I won't waste any more time on that. It'd take me a while to decipher that. This is what you do in that data structures class. Part of it is you go through items like that. Big part of how you do this is you do it by hand. And if you got it on a piece of paper where you're doing it by hand, you know exactly what these numbers should be. And so that tells you, did I not go far enough column wise, and not go enough row wise, and so forth. Well, that's going to eat at me, though. I feel like I'm so close. I got something just a little bit off. Play it a little bit more. We are in the final week since there's no assignment on this. Okay, so get one on diagonals. That's right here. So let's print the matrix. Get zeros below it. I don't want to necessarily have that in every column. That's too many. But I more want it probably in for each row. So let's run that and see. Okay, so divide everything by 4. 4 divided by 4 is 1. -5 divided by 4 is -1.25. Clear over to the far right, 3 divided by 4 is 0.75. So that's working. Then we figure out our temporary number, which is always -1 times this. So I take -5 times 1 and add to 5 here, it gives me 0. I take -5 times this and add to 2. That seems reasonable, be 8.25. -5 times 0.75. -5 times 0.75. 75. And add that to -12. -15.75. So that's working. Okay, so that one works. Then we come up with our new temp number, which is wrong. It should be -8, not -1. So the temp calculation looking through my columns, that's correct. Print the matrix, come back here, change it to rows 2. Rows 2 equals %D /n rows 2. Oh, what'd that do? rows 2 is equal to 1. I get down here, rows 2 is equal to 2. So it is equal to 2. So that'd be 2, 1. Row 2, column 1. Row 2, this is 0, 1, this is row 2. Column 1, I see why it's 1. It's doing exactly what I'm telling it to. What I want it to be is this one, don't I? Or no, it should be this one. So it should be row 2, column 0. So I want it to be the same column than the current. Same column. So what it's looking at is 2, 1. And I want it to be looking at row 2, column 0. This. You might think, well, I could just subtract 2, but then that'll break my first one. And my first one was working, won't it? Like if I do a minus 2 there, see, it breaks the first one. I have a feeling it's more than just the minus 1 here. Because I want it to work against this one, against this, which is like 2 rows down. So I should cheat and just look at some code out there. I probably see exactly what they're multiplying it by. Let's see. See if I can easily tell. doing it all different than what I'm doing. Probably easier. Okay, so rows 2 is equal to 1. So if that's 1, this is accessing 1, 0. 1, 0 would be this one. So that's right. And this one I want it to access 2, 0. So this is always 0, which would correspond to the rows were on. Rows. Still not quite right, but better. It's now doing the temp correct, isn't it? This temp is now -8, which is -1 times the 8. But then it's not multiplying the -8 times 1 and then adding it to 8 here, because otherwise this would be 0. The new row 2. That'd be rows. Better. This is -8. It's getting 0 here. I'll assume all those are correct. In the interest of time, so divide everything here by 8.25. That gives us this. My next number is -9. That's perfect. -9 times that gives us 0. That's looking good. Then we want to get a 1 here, and I get a 3, which is our first answer, wasn't it? But going back up, it's not working now. It should be getting zeros above this. So getting zeros above the 1 here. Okay, so going back up the diagonal. And I expect it's the same thing. One of these should probably be rows. So if I actually print it out. Now you can debug this, but sometimes when you're working with multi-dimensional arrays, debugging it's a nightmare. It's just sitting looping through all the rows and all the columns. So sometimes your system out prints are a little bit better. Okay, so this is telling us it's getting -9, which is not. Wait a minute. 0. That's obviously not right. I wanted to get this. Row 1. 0, 1. That is row 1. Rows 2 is equal to 1, which would be 1 minus 1, which is row 0, which isn't what I want, is it? Oh, what have I done? I've hard-coded, haven't I? It's starting at row 1, when it should be starting at rows. Not sure if that's a problem. How could it have broke there? What did I have there? Was there a 1? A 1. And originally I had 2 rows, didn't I? So this should be rows minus 1. Boy, it's close. I got that one. Now I just got one more here. So it doesn't look like it's going all the way up. So it's like going 1 row, 2 view. Um, 1 row, 2 view. Continual rows is greater than or equals 0. Greater than 0 will be 1. It's probably going to break it if I do that. Let's see. I don't understand how it's breaking it where it's doing it. Because see, this is the first part where it's getting zeros below. It's like, how in the world can it be breaking at that point? Because I've changed the code where it's getting zeros above. Okay, so starting at rows is now 3 rows. 3 minus 1, starting at 2. I was really hoping I could figure this out before we're done, but we'll see. Rows 2, temp is equal to 0.9. That's right. I must not be printing out my matrix, which would help, I suppose, in debugging it. So right here, after I finish modifying my matrix, I should print out my matrix. Okay, so row 2, I'm on this row. I'm getting this number, the negative of it. That's correct. Get a 0 there. The next one, row 2 is 1, and my temp is wrong. I'm getting a 1 minus 1 is 0, 1. I'm getting 0, 1 when that's equal to 1. 0, 1, row 0, 1 is this number right here. I don't want that number right there. I want this one. So instead of row 2, can't be that easy, but we'll just try it. Just put a plus 1 there. And broke that other part then. That doesn't do it. I really will give up. It's only doing one row above it, not going to the top. I know why. This is going to take a lot of work to fix it. Because at this point right here, I needed another for loop. Brian T rows 2 equals, or Rx equals, I wouldn't even be able to figure it out in 3 minutes time. Does that make sense what the problem is though? Up here we have one big for loop for going down. And the problem was I had included the bottom portion where I was going up inside that for loop. Yeah, so here this is going down, and then within that you have another loop here where you're looping through the rows below it, and then all the columns. Going back up, see this is where we're going back up. I need another for loop here for the rows, and then I'm going to hit all the rows above it, so in reverse. But my design was very poor. I'm surprised it even worked with the two equations, two variables, with how I've written that. Because you can't have this in the same for loop as the one above. That's a shocking part, because it was even close, or did work on that one. Oh well, I'll go ahead and stop there. That was kind of fun though. I like things like this. Mainly because it challenges me to really think through the process. I think that'd be kind of a fun job working for a place to program Mathway. Have you been to Mathway? Yeah. See, I think that'd be a blast to program the programs behind that. Oh well.